As you know, all the continents on Earth have different climates, ecosystems, and cultures. But it wasn't always like this. In fact, this will also change in the future. Someday, our world will change beyond recognition. All continents will become one great land. What will it look like? Well, I won't be around for this, but let's find out, shall we? Let's peek at the world map. There are 7 continents: North and South America, Africa, Australia, Antarctica, Europe, and Asia. If you know this, congrats! You still remember something from elementary school. Now, have you ever noticed that their borders line up quite well with each other? For example, South America and Africa look just like 2 puzzle pieces. The scientist Alfred Wegener also noticed this back in the 1910s. After finding this out, he continued to assemble the puzzle and noticed that India and Madagascar line up with Africa just as well. But that wasn't the only strange thing about the world. For example, we found the fossils of the same ancient animals on completely different continents. Now, how's that possible? They couldn't have originated as a species in Japan and Central America at the same time. That's just preposterous, a special word I like to deploy now and then. Could some of them have crossed the ocean? That's unlikely, unless they're some kind of Olympic swimmers. Maybe there used to be some kind of natural bridge between these continents. But even though so much time has passed, if it really existed, we would have found traces of this bridge. And what kind of crazy builder would build a road that long? There were a few other strange things. For example, people found traces of the same mountains both in the US and in Scandinavia. What does it all mean? Wegener thought hard about it, and then it dawned on him. A brilliant discovery. In 1912, he presented his idea to the world. The general idea was that the continents move like icebergs on water. They're constantly converging and diverging. Now, we know that he was 100% right, but unfortunately, scientists at that time basically pelted Wegener with tomatoes. He lacked data and couldn't explain exactly how these plates move. Nevertheless, Wegener didn't give up. He wrote a book called The Origin of Continents. And finally, in the 1930s, the geologist Arthur Holmes filled in the blanks in Wegener's theory. Finally, the world... Oh, wait. We'll have to wait another couple of decades until the world realizes that this is true. People are kind of slow, huh? Anyway, now we call it the theory of continental drift. By the way, on a grammatical note, when we travel on a continent away from the beach to farther inland, we say we're going inland, rather than we're going incontinent. Big difference, don't mix them up. Meanwhile, the continents on Earth move along the mantle by several inches per year. Every few million years, they bump into each other and create the so-called supercontinents. Supercontinents are, as you might have guessed, huge land masses that consist of several smaller continents. We're still not sure how many of them existed before, but you've probably heard about one of them. It became the most famous because scientists believe that it was the only supercontinent in the history of the Earth. It was named Pangaea because Afar, Eurasia is too long to remember. Hey, just kidding. Pangaea from Greek means the entire Earth. Beautiful, right? This supercontinent existed for about 160 million years, but it broke up a very long time ago. That's why it's hard to even imagine what Pangaea looked like and how many things have changed on it. It was significantly different from our present Earth. For example, there weren't any mountain ranges that we have today. The CO2 concentration was 5 times higher than it is now, so the average temperature was much warmer. It's possible there wasn't even ice on Earth, only tropical forests. This Earth could be a greenhouse, and even the North Pole could be covered with rainforest. Sounds like a pleasant place. Dinosaurs witnessed all this, but we didn't. The first humans appeared only 2 million years ago, and the first Homo sapiens, which is basically us, appeared only 300,000 years ago. So, unfortunately, we as a species basically missed the cool continental drift part. But maybe one day, we'll be able to see what it could look like. You see, Pangaea wasn't actually the first supercontinent. There were at least 3 of them before it. The oldest one, Valbera, existed about 3.6 billion years ago. It became the grandma of all the continents we know today. Valbara included almost all of them. Then it broke up, like a couple on a bad date, and we got her grandkids, Ur, Kinnerland, Nuna, and so on. Eventually, it came to Pangaea. Now we know that they form every 600 million years. That's called the supercontinent cycle. That means one day on Earth, everything will merge together again. But when and how will it happen? Well, first of all, we need to clarify something. We have one supercontinent, right? Basically, one huge island. That means the rest of the world is now a superocean, except for a couple of small islands, maybe. The ocean at the time of Pangaea was called Panthalassa, and our cool, mysterious Pacific Ocean is actually just its pathetic remnants. The other two big oceans, the Atlantic and Indian ones, were born when Pangaea started to break into separate pieces. So when these oceans close, completely drying up, new supercontinents are formed. And every time they close gradually and very slowly. It means that the Pacific Ocean is shrinking in size right now. Yep, it loses a few inches a year. Boy, I could sure lose a few inches a year. Now, it's hard to imagine, but in the future, it will become an ordinary puddle. It will disappear together with the Arctic Ocean, and that's inevitable. But when it happens, a new supercontinent will appear, Amasia. The birth of Amasia was predicted by scientists from the University of New Curtin in Australia. They did some very complex calculations on a supercomputer. They uploaded the continental movements of the last 300 million years or so. And then, based on these calculations, the computer predicted what the future holds for us. We learned that one day, the Americas, both south and north, will collide with Asia. And this collision will create a new supercontinent with a very original name. As already mentioned, the Pacific Ocean will one day completely disappear. On the other hand, the Atlantic Ocean is growing right now, pushing both Americas to the west. So when Amasia appears, this ocean may become the new largest ocean in the world. So here's what it's going to look like. Both Americas will collide with East Asia, and although it's hard to predict, some sources claim that Antarctica eventually will find its way to South America. Australia will also play a huge role in this. It may connect America and Asia. So, it won't be down under anymore? Guess not. And if humanity somehow still exists, that means that you could hike from France to Australia or from South Africa to Argentina without getting your feet wet. So, here's a solution. If you can't travel right now, just wait 300 million years. And no, that doesn't count the wait time getting through airport security. Scientists also used to think that Amasia would gather around the North Pole, creating a huge ice cap and cooling the planet. However, now they think that this is very unlikely. It's probably going to be somewhere in the middle of the poles. However, this doesn't mean that the Earth will remain as friendly as it is right now. The Earth of the future will be radically different from what we know. The sea level will become lower, and the Amasia will consist of vast, very arid areas with high daily temperature ranges. Yep, it's going to be super hot. The ecosystem will completely change, but it's quite difficult to say what it will all lead to. The more data we receive over time, the more accurately we can predict the future of our planet. At the moment, all these are just theories, and scientists note they're still far from being proven. But even so, the results of the team's work are very impressive. They tell us a lot not only about the future of the planet, but also about its past. Wouldn't it be great if humans could live up to those times? We could watch from distant space how our home planet is changing. It's fascinating and a little bizarre at the same time. Do you know how many continents there are on Earth? That's an easy one, 7. But wait a second, aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist, or at least they used to. They are hiding under other landmasses. Peekaboo! Researchers have recently discovered one continent just like that. It's called Greater Adria. Sound familiar? Yes, it has something to do with the Adriatic Sea. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's eighth continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint – under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low, and that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, and there would still be 7,000 feet between it and sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other, one goes down while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Yep, the coldest and one of the hottest places on Earth were once the same territory. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean. These islands are all that is left of an ancient landmass. They have a cold climate. The islands feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The lost continent's landscape probably resembled that of New Zealand. Now, while we're in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right of the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. But there is evidence of an even greater landmass, the lost continent of Mauritia. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steps of Mauritia. They found a mineral that exists in rocks which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. The local dishes would definitely be spicy. Now, speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Sahul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side and the Greater Australia on the other. Back then, Bali stood at the southernmost tip of Asia. Biologists were among the first scientists to notice the split. Species developed differently on Sunda and Sahul. That's why Australia has unique animals, such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. Today, the two islands are separated by the Torres Strait, but it's quite shallow, less than 65 feet. It's a reminder that this was once a single landmass called Sahul. Another ocean strait that isn't too deep separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels were 300 feet lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Talk about the ultimate backpacking route. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangaea was a supercontinent that included all of the continents. Its name is in Greek, and it simply means all Earth. But Pangaea started to crack up. The biggest gap formed between the Americas on one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 1 inch per year. Doesn't seem much when compared to the average human lifespan, but in the end, all the continents will reconnect with each other, forming a supercontinent. And it wouldn't be the first time in Earth history that this happens. Honestly, I'm not going to wait around for that. Wow, this port is so buzzing. Thousands of people come here every day to work, cargoes come and go, fishers are weighing their catches for the day, and even posh cruise ships pop in here to show this idyllic place to all the people on vacay. The ocean shore is fantastic. People walk along the beach eating ice cream or building sandcastles. Oh, and by the way, right now we're standing where the Sahara Desert used to be. Normally our lifetime is too short to see any major changes. We don't notice mountains rise or the way rivers change their course. Entire valleys may be sinking, but it usually takes too long for them to sink entirely. Still, a group of scientists recently noticed there's a new ocean being formed really fast, and we can even witness it appear. Look here! It's the Afar Triangle. There's the Horn of Africa Peninsula not far away. It's the exact site where the sixth ocean is being born at the moment. Wherever you are, you're basically standing or sitting on a tectonic plate. You're just sitting on a couch watching this video? Cool. Your couch is standing on the floor makes part of your house is standing on the ground, and if you take a deeper look, it all stands on one of 15 principal tectonic plates. Together, these chunks are referred to as lithosphere. It's like a nice apple pie. The crust is the lithosphere, and the fragile apple filling is everything that's on the planet's surface. If the crust cracks, the filling leaks out. And this is what any earthquake is like. A tectonic plate, aka the crust, moves. The filling, also known as houses and people, is disturbed. Africa is made up of two plates, the Nubian and the Somali ones. Yeah, that's a large pie. And it seems like these two plates are constantly separating. It leads to an oceanic spreading ridge. It looks like the African continent is literally unzipping a part of it at this moment. A 345 square mile chunk of the Sahara Desert just split, so the magma rose. It triggered a series of earthquakes across Ethiopia, Eritrea, and Djibouti. And it's not just some minor earthquake. There are lots of fumes rising from those fissures, and it smells like sulfur. Phew! The eruptions slowly push the old lava sediments away, which is followed by creation of the new seafloor. The crack is filled with magma, and when it cools, it forms the new oceanic floor. If this process doesn't stop, the Red Sea will finally flood the area, forming the Sixth Ocean, and Africa will be split into two parts. So we'll basically have two Africas. But wait. Neither you nor your grandchildren are going to see that Sixth Ocean. You'll only have 5 of them throughout your life. Same with our future generations. Same old Pacific, Atlantic, Indian, Arctic, and the Southern Oceans. Before the oceanic floor gets solid, and before the Red Sea actually starts flowing in there, many thousands, if not millions of years must pass. The continents move as fast as your nails grow. And imagine that the longest nail ever seen in history was the thumbnail of an Indian man reaching almost 6.5 feet before he cut his nails. It took him almost 60 years to grow it. Now think how far the continents will have to move by the time you celebrate your 100th birthday. Spoiler, it's not going to be very far. But anyway, you can witness some minor changes that take place even now. All those cracks that may not seem that significant so far make all the landscape in the Afar region look really unique. There's a couple more reasons for this uniqueness. Meet Erta Ale in Ethiopia, the volcano famous for its world's longest-lasting lava lake. It's located in the Afar Depression, also known as the Afar Triangle. By the way, depression refers to the sunken area. There's nothing sad about it. It's not the only volcano in this area. Eritrea, known as the Nabro volcano. It's never erupted, yet the lava in this area is pretty active. More volcanoes are to come because of the tectonic plate movements. They pull away from each other, and the Earth's crust gets thinner. The weaker the area is, the more volcanoes there are. Okay, the plates are separating, and it's kind of inevitable. It's just the question of time. This process is also called the Afar plume. We'll get more volcanoes, it's inevitable either. But how does it happen? Remember that apple pie? Yes, it was delicious. Well, things are actually much more complicated. The outer layer we walk on is relatively delicate and is made up of multiple broken pieces. It's like the eggshell or a lattice top on a pie. Let's take a deeper look at all the ingredients of this pie. If you cut a slice, you'll see it's made up of many parts, and there's something called the asthenosphere under the lithosphere. It's part of the Earth's mantle. Yeah, complicated. So the asthenosphere gets heated from within, and it rises, just like the dough when you put it in the oven. Remember those cracks on the surface of a freshly baked loaf of bread? Man, I'm getting hungry. Anyway, this is basically what happens to the Afar Triangle, and those cracks make this area split, creating those famous rifts and valleys that will possibly become so large and will probably get flooded so that the world's sixth ocean will appear there soon. Or not. Nobody's sure about it. Okay, but since the tectonic plates and, which is logical, all the continents are always on the move, we'll probably have more continents in the future. The answer is yes and no. If a part of Africa does split, we'll get one more continent, which is going to be even smaller than Australia. But there's one more possible way of how things will go. Chances are, in the next 250 million years, in the distant 250 million years, there will be no more transatlantic flights. And a walking trip from Japan to Chile will be possible too. Way too long, but possible. It's all happening now, and the first results will be noticeable in some 50 million years from today. I won't be around then. Australia will move towards Southeast Asia, and it's going to fit in just perfectly. And Africa will be pushed to Southern Europe. Still, these transformations will take a really long time. People and continents have something in common. Remember that continents move as fast as our hair and nails grow, just about 1.2 inches a month. Some of them move even 5 times faster though, but even this speed is too slow for 4,500 miles distance between Africa and Europe. One theory tells us the things we've already seen before. Well, you didn't see that with your own eyes, neither did any of your ancestors who came to America across the Atlantic hundreds of years ago. The fact is, all the continents were once one landmass known as the Pangaea Supercontinent. Even though it formed over 300 million years ago and split about 180 million years ago, give or take, it might come back together. So kangaroos can easily migrate from Australia to the UK if they feel like it, but the latter might be accidentally crashed while all the continents merge together. The Americas would collide, Antarctica would drift to them, and it all will merge with the already collided Africa-Eurasia. In this scenario, one large ocean and one large continent will appear, namely Novo Pangaea. Another possible scenario claims the continents might merge into the uniform landmass or form a circle with a large sea inside and the super Pacific Ocean outside. This continent is referred to as Pangaea Ultima. The third theory might be already coming to life. The Pacific and the Atlantic Oceans might just cease to exist, forming the new ocean basin. Eurasia will be split to form a new ocean, and all the continents will migrate to merge into the supercontinent Orica. And the fourth and last theory claims that the Pacific and the Atlantic Oceans will remain almost unchanged, and all the continents but Antarctica will merge into one, leaving poor Antarctica even more isolated and abandoned than it is now. Nah, don't feel bad. Since all the continents keep drifting northwards even now, it's quite probable that almost all of them will meet up somewhere at the North Pole. Our planet has 5 oceans: the Pacific, Atlantic, Indian, Southern, and Arctic, not counting Billy Ocean. But it seems there's a 6th one out there too, it's just that you can't see it. Scientists have found evidence of large amounts of water hidden in the transition zone. That's the boundary layer that separates the upper and lower mantle of our planet. That boundary goes hundreds of miles deep down below the surface. Natural diamonds usually form in the mantle, but at depths of up to 155 miles. Some of them are very rare. They may come from deeper depths. That was the case with this fascinating diamond that formed 410 miles below the surface. The gem was big enough for scientists to study it and determine what it was made of. They were surprised when the composition of this very rare diamond showed that it was formed in pretty watery conditions. Because of that, such a diamond wouldn't be worth much in jewelry stores, but it was priceless in the lab. So, could this mean there's an ocean under the surface of our planet? It would definitely get us closer to the idea Jules Verne had about this whole magical secret world inside Earth, including the ocean. But that's not exactly the case. The water is there, true, but it's not like you can enjoy the view watching waves splashing around like on the surface of our planet. The water is actually stored within the minerals. That's why this area is so wet. Let's now move to Africa to keep up with the story, or to be more specific, to a spot called the Afar region. It's part of Ethiopia and a place where 3 tectonic plates meet. Tectonic plates are large pieces of our planet's crust that slowly move. These movements cause earthquakes and produce volcanoes, mountains, deep underwater valleys we call trenches, and so on. And the Afar Valley is where the Arabian, Somali, and Nubian plates meet. Together, they form an intersection in the shape of a Y. Why? Let me tell you. These plates are moving all the time. The Somali plate is moving southeast toward the Australian and Indian plates. The Arabian plate is moving north, getting closer to the Eurasian plate. At some point, it will close the Persian Gulf. This movement of plates has created something we call the Great Rift Valley, considering there are, all these cool rifts. The Aden Ridge to the east, the Red Sea Rift to the west, the Oculus Rift and the East African Rift to the south. But the East African Rift is something we want to focus on, because this one could be the key to this potential sixth ocean, but this time on the surface. A continental rift is a spot where two tectonic plates that form a single continent start to separate. Here it's the Somali and Nubian plates. Together, they're parts that make up Africa. If they keep moving in separate directions, this currently continental rift may become what we call an oceanic spreading ridge. In other words, when the plates are far enough apart from each other, there will be an enormous crack between them. This way, magma will freely flow up from beneath them. It'll be cool and eventually start creating a new ocean floor. Africa will be split into two parts, and there will be a new ocean flowing between what will turn into two mini-continents. Nope, it's not time to get your swim trunks and sunscreen yet. Even if the Somali and Arabian plates do move far enough to form an oceanic spreading ridge, it'll take millions of years before this happens. So I guess it's more interesting to stick to exploring this sixth ocean below the Earth's surface for now. The idea of subsurface oceans goes beyond the borders of our planet. It's possible many moons and planets out there have them too. Our home planet is the only one we know about with consistent bodies of liquid water on the surface, true. In our solar system, we circle around the Sun in something called the habitable zone. The temperature and atmospheric pressure within this zone allow water to remain in liquid form all the time. But a couple of moons in our solar system could also contain significant amounts of water under their surface. Enceladus, one of Saturn's moons, is the first one. Enceladus is a small frozen ball 7 times smaller in diameter than our moon, but it's the 6th biggest moon of Saturn. Nearly a decade ago, a spacecraft found evidence that there was a large ocean under its surface. It found and sampled water from the eruptions that resembled geysers. A geyser is a rare type of hot spring that erupts and sends jets of steam and water into the air. You know, like Old Faithful in Yellowstone? Well, this water was erupting through fissures in the ice at the south pole of the moon. That means there might be a liquid ocean under the thick layers of ice. The ocean there is almost nothing like ours. The ocean on Earth is relatively shallow, on average 2.2 miles deep, and it covers 3/4 of our planet's surface. It gets colder the closer you come to the seafloor, and is warmer if you stay close to the surface because of the sun's rays. But the subsurface ocean on Enceladus is at least 18 miles deep. It's cooler at the top because that part is near the ice shell, and warmer at the bottom because of the heat coming from the moon's core. But both our ocean and the ocean on Enceladus are salty. Enceladus is one of the few places in our solar system that has liquid water, which makes it an interesting spot to search for signs of life. Another one is Europa, one of Jupiter's moons. Scientists think similar eruptions of water could be happening there. Knowing there are such geysers there tells us these moons have their own source of energy. Maybe the energy that makes the water erupt comes from gravity or radiation. The same energy could keep a large body of liquid water under the ice. It could even support some forms of life. There are thousands of planets beyond our solar system that orbit other stars. Some are even in the habitable zone. Over 1/4 of the ones that we know about could have liquid water, but the majority of them probably have oceans under their surface, like Enceladus and Europa. Pluto might be on this list too, since it's possible it hides a liquid ocean under its thick frozen shell. This subsurface ocean likely formed long after the dwarf planet did, after the heat coming from radioactive elements in Pluto's core melted some of its ice. There's also something called water worlds. Those are moons or planets with global oceans that are more common than we thought. I mean, some call Earth a water world too. 71% of its surface is water after all. And when you look at our home planet from space, you mostly get those blue marble pictures. When exploring other planets, especially those outside of our solar system, researchers often go with a policy of follow the water. After all, water is the main element we know that's necessary for supporting life. And when there's a water world that's close to its parent star, Scientists assume it must have formed way farther and then moved closer once its orbit shrank. The composition of the planet was set when it was in a colder orbit, or, in other words, when it made a wider circle around its star. We call the process of orbital shrinking a migration, and if water worlds are really that common, it can be proof that migration really happens. Exoplanets are all those planets that orbit around other stars, not our Sun. Some exoplanets may have oceans that are way deeper than any of those in our solar system, hundreds or even thousands of miles deep. Our Mariana Trench is scary, and it's not even 7 miles deep. And those exoplanet oceans are, wow, almost bottomless.
Scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia, hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallachia and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylacoleo. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan aurum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand, along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Argoland. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently they finally found its remains. Turns out, poor Argoland's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Argoland were pushed upward, grabbing the younger rocks on land. Because of this, Argoland broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now the islands are home to unique species both on land and in the coral reefs nearby. Mauritia broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zircons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future. So many asteroids pass through our solar system, and we don't even know about it. Those are rocky pieces of material left over from the time when our solar system was forming, about 4.6 billion years ago. They move around the sun, but not in the way planets do. We're talking about true rebels that prefer to follow some pretty strange paths. Plus, they spin in different ways as they travel between planets and other space objects. And the majority of them come from the main asteroid belt that's located between Jupiter and Mars. Most stay there. But Jupiter has quite a strong gravity, so it can push some of those flying rocks in different directions, and towards us too. They're sometimes round, and sometimes they have odd shapes with pits and holes from all that crashing into other space rocks. As we currently know, there are more than 1 million of them in the main asteroid belt, and that's all good until some of them move in our direction. NASA keeps an eye on them, so we know everything's fine, at least for now. But that wasn't always the case with our beloved home planet. If Earth could talk, it would probably share so many crazy asteroid stories. We're talking about those space rocks that left impact craters we call domes. They have a specific shape with a raised center, similar to when you throw a pebble in a pond and see some water splashing upward. But we'll never be able to learn about many others. I know this raised center sounds like something you're supposed to see right away, especially if an asteroid that once slammed into the surface was big. But we're talking about millions and millions of years of erosion, so wind, water, and even gravity do what they do best and erase traces. They wear down impact domes, and some sites even end up hidden under layers of rock and dirt, or they disappear forever because Earth's tectonic plates keep moving around. Check out the Moon. It's experienced many collisions too, but over there, there's no ocean or tectonic plates moving around, or even wind to slowly, through millions of years, erase craters from its face. Basically, its entire history is written on its surface. But Earth has its own forces that can erase such places as the Vedafort impact structure and the Chicxulub crater. You know, the famous one that wiped out the dinosaurs? Luckily, scientists have new methods to find ancient craters. They often focus on the mess impacts made, which means the materials they threw around. And the Australian continent is especially interesting since we're talking about a playground for asteroid hits. By that, I mean ancient supercontinent Gondwana that dominated the South hundreds of millions of years ago. Experts know about 38 impacts, plus they speculate about 43 more. Some structures are relatively small, while others are big and completely hidden. And recently, a scientist named Tony Yates has discovered strange underground magnetic patterns in New South Wales, Australia. Yay! New clues of a giant asteroid impact! And when I say giant, I really mean it. It's a structure 323 miles in diameter. This might be the largest impact site ever found. This spot is called the Deniliquin structure. Its magnetic patterns show characteristic ripples around the center, like when a rock hits the water. There are also fractures that go outward from the center. And it seems rocks from inside Earth ended up pushed into these fractures. That's a typical story for big asteroid impacts. This structure was probably located in eastern Gondwana hundreds of millions of years ago, way before it split into several continents, including Australia. At the moment, all we know about this crater is what we see on the surface. To find more information about this collision and get some proof, we'll have to drill into the ground. An asteroid this big is definitely not a joke. It could have caused a massive ice age and maybe even wiped out around 85% of species, even more than the asteroid that ended dinosaurs. In 4.5 billion years, which is how long our planet has existed, it's been punched by hundreds of big asteroids. But that doesn't mean every space rock that enters our atmosphere really makes it all the way to the ground. Most of those that manage to pass the atmosphere are relatively small, for instance, 3 feet across. That's good for us because any space rock that's less than 82 feet in diameter most likely won't make it past our planet's atmosphere. Since these space rocks come towards us very fast, they heat up the gases in the atmosphere, which burns them away. By the way, once cosmic intruders enter our atmosphere, they turn into meteors. And in most cases, they don't cause much damage, if any, as they fall down. But we used to have way larger things flying around and crashing into Earth. At least 190 of them have left scars you can still see today. One of the really big ones is in South Africa. It's 99 miles wide. It's actually the largest. At least that's what scientists think at the moment because they still need to check as many details as possible about this new crater in Australia. This one in South Africa formed about 2 billion years ago, and an asteroid that created it was probably larger than the one that had wiped dinosaurs away. And when an asteroid is bigger than 0.6 miles, it can have really big effects across the world. This impact was so strong that it could have caused fires everywhere and thrown lots of dust into the air. And when you have so much dust in the atmosphere, the climate on the planet can change for months or even years. Then we also have the most popular asteroid that made a giant hole we today call the Chicxulub crater. You know the story. It crashed into our planet 66 million years ago when dinosaurs were wandering around, catching food, falling in love. Basically, just doing their thing. The crash itself didn't erase them right away. It threw a lot of debris into space, and when it fell back to Earth, fires and flames were everywhere. The hit also produced a big cloud of dust that covered the planet for years. This cloud blocked the sunlight, which harmed plants and entire food chains. Even those dinosaurs that survived the crash and such difficult conditions had a hard time finding food, so they didn't make it. At least they left us many fossils and turned into the inspiration for movies and stories. A long time ago in Canada, something big crashed into our planet and left a big hole we today know as the Sudbury Basin. People used to think it was an asteroid, but now some experts think it might have been a giant comet made up of a mix of ice and rocks. The hole is almost gone now because of weather conditions though. But people still get to mine iron and nickel there, and at the same time find the leftovers of whatever space object fell there. If you move deep in southern India, you'll find a big hole called Lonar Crater. Locals stumbled upon it 200 years ago and believed it might be from a volcano. But now we know it's a trace from a meteor that crashed into the ground about 35 to 50,000 years ago. What's so special about this crater is that it's the only one known to have formed in a type of rock called basalt. Around the crater, there are hills covered in trees, and animals like peafowls and gazelles live there. Birds also like to visit the lake near the crater during the winter. And the lake itself is quite interesting too. It can turn pink because of all those tiny organisms that live there. But this color change doesn't last long.
Surprise! There's more than 7 continents on our planet. Argoland, a hidden continent, may help us understand how our planet will look in the future. To find out how it hid from us and what secrets it holds, well, you'll just have to keep watching. Ready for a mystery? Scientists have been looking for a piece of land that's been missing for over 100 million years. Not exactly newsworthy, since people search for information about our planet's history all the time. You'd think it was probably this minuscule island somewhere in the middle of an ocean. Well, you'd be wrong, because this continent used to be as big as the entire US territory. For a long time, geologists have been wondering whether a massive chunk of contemporary Australia vanished into thin air. Some believed it was simply hiding somewhere on the ocean floor. But thanks to some Dutch specialists and 7 years of investigating, We now know there are bits and pieces of this lost land mixed underneath the lush jungles of Southeast Asia. The continents we see in our geography manuals these days are like scattered pieces of a puzzle. There's even a nice experiment you can conduct to see for yourself. Find a world map online and print it out. Cut out all of the continents and play around with them for a while. You'll see they all fit together. Probably the most striking thing you'll see is how South America perfectly fits near Africa. If you close up the oceans that were formed in the last 200 million years, the continents look like they form a giant letter C. And that C is what scientists call the supercontinent Pangaea. It was swimming in an ocean called Panthalassa, and the inner portion of that letter C had a smaller stretch of water called the Tethys Ocean. It is in this small ocean where things get interesting. Back in the Jurassic period, this vanished continent, which scientists started calling Argoland, vanished and left a hole in Australia, now known as the Argo-Abyssal Plain. Geologists initially believed this was all due to a process called subduction. It's when one piece of the Earth's crust dives under another and recycles it into the planet's mantle. Usually, specialists track this continental vanishing through off-scraping. That's how they figured out, for instance, that India bumped into Asia and gave us the majestic Himalayan mountains. But for Argoland, things were a bit more complicated. Bits and pieces were popping up in places like Myanmar and Indonesia, but they behaved like these time-traveling relics, looking way older than when Argoland supposedly separated from Australia. It immediately raised the question, if one continent can behave so weirdly, how many others are out there doing the same? Thankfully, scientists have now put together the entire timeline of Argoland and figured out its mystery. It didn't sink or get swallowed up. It simply transformed into an archipelago, breaking into smaller pieces, called microcontinents, and floating away from Australia. These mini-continents then took a little journey before settling down in Southeast Asian jungles. This discovery fits right into the whole Pangaea puzzle. It helps us better understand how continents break up and make up, all in one discovery, revealing secrets of biodiversity and climate back from in the day. If you'd like to find out more secrets about history, civilization, or random day-to-day objects, be sure to like this video and subscribe to the channel. Like, for instance, the mystery behind this invisible species line in Indonesia. It's called the Wallace Line, named after the British explorer Alfred Russel Wallace. Over 150 years ago, Wallace was on a journey around the Malay archipelago, visiting thousands of islands. What he found was that animals on one side of this invisible line were considerably different from ones on the other side. This invisible line is like a wall between marsupials and tigers, for instance, or honey-eaters and trogons. But now we know that around 35 million years ago, Australia broke up with Antarctica and collided with Asia, and this continental love triangle triggered significant changes. It didn't just change the way the land looked, it also messed with the species of animals on each side of the Wallace Line. In more recent times, a bunch of specialists published a study saying this collision and climate chaos made Asian species comfy living in the Malay archipelago. Meanwhile, the Aussie animals weren't as happy with the new environment. It was too hot and wet for some, and others just couldn't handle the tropical island lifestyle. The discovery of this continental shift towards Asia might also explain a recent finding of a human species that didn't seem to make any sense either. You see, in this hidden cave in the Philippines, archaeologists stumbled upon a new human ancestor. It seems that about 50,000 years ago, on the island of Luzon, there was this ancient human-like species. The lead researcher believed this finding was crucial for understanding human evolution in Asia, and it named this new species after the island, Homo luzonensis. Now, here's where it gets a bit confusing. The bones found by archaeologists had one small problem. They had a weird mix of traits that hadn't been seen together in any other hominid species. Smaller teeth, similar to ours, yet hands and feet that were more like our ancient humanoid ancestors. It was those throwback limbs in particular that connected this human species with the long-lost Southern Territory. That's because they have this primitive look, like these hard-to-pronounce guys, for instance. Only these two species are separated by 2 to 3 million years of time in evolution. Many have wondered, is Homo luzonensis really a new species? Not everyone is convinced. But it may also explain why living creatures are also affected by the constant shifting of the land underneath us. Now, just because they haven't changed much during our lifetime, it doesn't mean our continents will look like this forever. They evolved from this large megacontinent, and they'll most likely end up in a similar position in the future. On that note, a geologist from a European university tried to predict the future of Earth's supercontinents. As a starting point, he used an earthquake that occurred in Portugal back in 1755, when tectonic plates behaved a bit differently than they should have. After years of research, he came up with a theory in 2016. He believed that the stitches between these tectonic plates might be coming apart, setting the stage for a bigger rupture. It's like when glass cracks between two holes in a car windshield. If this happens, a subduction zone could stretch from the Mediterranean all the way up past Ireland, bringing volcanoes, earthquakes, and new mountains to these areas. If all goes according to this plan, the Atlantic Ocean will disappear, and so will the Pacific, turning into one large stretch of water. Instead of the 7 continents we know today, we'll get a new supercontinent, which he called Arica, because it would have Australia and the Americas at its heart. Now, it's not the only possible scenario, though. Novo Pangaea might be another, and it's easy to foresee. The Atlantic stays open and the Pacific closes. Then there's Amasia. For this one, you'd have to imagine the Arctic Ocean closing and the Atlantic and Pacific staying open. Everything shifts to the north around the North Pole, except Antarctica. One final scenario would be called Pangaea Ultima. Slow down the spreading in the Atlantic, and a new subduction plate pops up on the America's east coast. Well, either way, if all the continents collide in the future once more, some say it won't be fun to experience. It's believed that in around 250 million years, we'll feel like we're being trapped in a sweltering, soggy plastic bag. Weirdly, that bag will be the best place to live on Earth, the coastal areas. As for the inland spots, they'll be sizzling, like a desert on fire. Many of the species of animals we know today might not make it. As for us humans, we'll need to be creative if we want to withstand the heat. We should be thankful, though. These digital models are still great because we can use them to test all sorts of interesting ideas. For example, how these supercontinents would mess with tides. Taking future space travels into consideration, these models can help us understand the climates of exoplanets too. Those are located outside our solar system.
Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangaea. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangaea began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangaea's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, that piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, We can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place. It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zircon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research, but this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. And this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zircon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritia, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritia was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritia was covered in water when India broke away from Madagascar, something like 85 million years ago.
I'll bet you've heard of the lost civilization of Atlantis sinking into the waters off the coast of ancient Greece. The story is supposed to be a myth, but have scientists finally found the lost city? Not sure about that, but they did find a lost continent. Wait just 1 minute, I've lost socks, keys, and even a few marbles. But how careless do you have to be to misplace an entire continent? We'll have to ask our planet about that one. Earth lost what was called Greater Adria between 100 and 120 million years ago. So, how did that happen, and where did it go? The only way to describe the process would be kind of like a snake slipping through rocks or going down into a hole. It's easier to imagine losing a continent when you think about how hard it is to find a snake that's escaped your curious stares. Most snakes don't leave trails. In fact, if you weren't around 100 million years ago to watch that snake slide beneath a boulder, and I wasn't, you'd never know it happened. Just like scientists might never have found Adria if it weren't for the snakeskin, the mountains. Let's say your fleeing snake slithers under a rock. It's long past due for a shedding, so its old skin scrapes off and bunches up right there in that tiny space between the boulder and the ground. That's what Greater Adria did. When it broke off from a humongous landmass known as Gondwana, stick around for more on that here in a few, the Greenland-sized chunk headed north. When it eventually crashed into Europe, it slipped under and caused the meeting place of the two continents to fold and scrunch up. For years and years, it just kept going, and those folds kept growing. In the end, it left behind very obvious and famous traces. You might even have gone skiing on them during a winter vacation. I'm talking about the Apennines and the Swiss Alps. Professor Douwe van Hinsbergen, the geologist who led the research team responsible for this colossal discovery in September 2019, has his own analogy. He compares this folding action to what happens when you stick your arm into a small space and your shirt sleeve can't fit through. It bunches up, and those bunches are like the mountain range. You might be wondering if other mountain ranges have similar origins. They do. Ever push sand together with your hands? Your hands work like shifting landmasses, and those peaks of sand you created are a mini version of the Rockies. The snakeskin, your shirt sleeve, the sand. The point here is that mountains get left behind when massive chunks of land smash into and slip under each other. But what about the disappearing continent that leaves them? What happened to Greater Adria itself? Just as a snake burrows underground for the winter, Adria kept sliding beneath the surface. Dr. Van Hinsbergen thinks she's probably nice and cozy about 900 miles under southern Europe right now. But wait a minute, is Greater Adria still a continent if she's underwater or under land? Is a snake still a snake when it's underground? Of course it is. In fact, I know a continent that's mostly underwater yet isn't lost at all. Ever heard of Zealandia? It's also called the New Zealand continent or Tasmantis. It looks like an archipelago, which is a string of islands. But if you peek under the water, you'll see that it's really one continuous piece of submerged land with mountaintops poking out over the surface. Those peaks are the islands. Zealandia is categorized as a microcontinent, which then begs the question: what is a continent anyway? That's a matter of some debate. In fact, we Earthlings can't even agree on how many continents, not counting the lost and micro ones there are. Generally, a continent is an enormous landmass. If you're from the US, you heard that there are 7 of them: Africa, Antarctica, Asia, Australia, also called Oceania, Europe, North America, and South America. European school kids, however, combine Europe and Asia into Eurasia, so they only learn 6 continents. South Americans also recognize 6, but they keep Europe and Asia separate and combine North and South America instead. What's even stranger is that everyone seems to agree that Australia is a continent, while Greenland isn't, and has to make do with the title of world's biggest island. Poor Greenland. This all has something to do with the tectonic plates that lie beneath the continents, but that's a discussion best left for another video. So, where did all these continents come from in the first place? Well, if you've ever looked at a globe or a map, you probably noticed that the 2 great landmasses surrounding the Atlantic Ocean, North and South America on one side and Europe and Africa on the other, seem like puzzle pieces that could be pushed together to form one even more gigantic mass. You might also know that there's a name for that mass: Pangaea. Scientists think Pangaea, a supercontinent if there ever was one, broke apart 175 million years ago. But not into those 2 big left and right puzzle pieces we have today. Instead, the split probably ran horizontally, leaving a connected North America, Europe, and Asia on top, a mass called Laurasia, while South America stuck it out with Africa, Antarctica, and Australia in a mass known as Gondwana. Yes, that very one that Greater Adria would break free from later on. So, if you took all of Earth's landmasses, continents, microcontinents, islands, and archipelagos and squished them together, would you get the original blob of land known as Pangaea? Nope. Not only would you be missing the parts of continents that lie underwater, like the masses connecting archipelagos, you'd also be missing all the ones lost over time. Oh yeah, there are others besides Adria. Scientists are looking for them, and they've already found some. One of those lost continents is the Rio Grande Rise. It's a stretch of underwater seamounts that's been dubbed Brazil's Atlantis. Greater Adria lay somewhere between North Africa and southern Eurasia. Hey, that's right around the Mediterranean Sea, and the Mediterranean is where Greece and Athens are. So, Greater Adria must have been Atlantis, right? Doubtful. Historians think Plato made up the story of Atlantis, but could it have really happened? You might think so if you believe the story of Greek deities punishing the civilization for starting a beef with Athens. But a more scientific theory would propose that Atlantis was simply flooded. Or perhaps it could have been one of the islands scraped off and left behind when Greater Adria dove under Europe. Disappointing as it is to say, the one thing we can't be sure of is that Adria itself wasn't Atlantis. The tectonic forces that shoved the continent under Europe did so over 100 million years ago. That's about 80 million years before any human showed up on our planet to start a conflict with Athens or anyone else. If you look at all the world's continents like broken puzzle pieces that formed a shattered Pangaea, you could say that Dr. Van Hinsbergen and his team have spent the last 10 years trying to put that puzzle back together. And like actual puzzles, it's hard to do that when you're missing a bunch of pieces. I'm looking at you, Adria. But they have fancy geological equipment that tracks the magnetic record left behind in the rock's minerals. You see, every rock, stone, and mountain has a sort of imprint of the time and place it was created. It all has to do with the Earth's magnetic poles. They change every now and then in a process called geomagnetic reversal. So, in a nutshell, the specific magnetism of certain sediment and minerals works like a map and calendar. And that's how they know where Adria came from, where she ended up, and who she met along the way. By studying the magnetism of these samples, the team also found out another interesting detail. Greater Adria not only crashed into Europe, but she was also spinning on the way there. A twirling, dancing mass of land whose carefree trip northward would be cut short by an unexpected roadblock known as Europe. Hey, that would make for a great bedtime fairy tale for the kids. Now, my only remaining question is, if Greater Adria dove beneath Europe, could she rise again? It is possible. Continents keep shifting, and they remain on the move today. But they tend to go at a snail's pace. So, check back in another 100 million years, and we'll see how many continents second graders are learning about in the future. I won't be here, though. I'll probably retire. There are entire communities of unusual tiny organisms that live in lagoons in Patagonia, and they are some of the first forms of life ever. No one had known about them until two scientists, Brian and Mauritia, went to explore certain areas in Patagonia. Now, Patagonia occupies nearly half of Argentina, and few people live there, only some farmers and sheep ranchers that mostly stay near rivers and grow things such as apples, pears, and alfalfa. A long time ago, it was a wild and distant place where Indian tribes lived. But this time, we're going to follow the tracks of life forms that appeared long before humans and look closer at these interesting microorganisms Brian and Mauritia found. Those two had to drive for 9 hours on some rough roads to reach their destination. They stayed in a small village. Only 35 people live there. These people depend on just one spring because it almost never rains there. On the last night in the village, Brian realized that satellite images he had taken had shown a set of lagoons that were only 10 miles away. The next day, the small team jumped into a car and went up the road as far as they could until it became too difficult to drive. They continued hiking the rest of the way. It was hard because they had to carry water to deal with the intense sunlight. In some spots, they ended up sinking up to their knees in a slush made of salt. Up there were 12 lagoons with perfectly clear waters. The place itself didn't offer much except for very acidic and salty water and intense direct sunlight. But it was kind of like traveling back in time, because those conditions were like what Earth looked like many, many years ago. When Brian examined the lagoons, he was surprised to see many unusual microorganisms there. We call them stromatolites, and they're so small we can't even see them without a microscope. But they get together and form large communities. In the past, many unusual species lived this way. For example, cyanobacteria. They were important back in their time because they produced oxygen. Earth, in its initial stages, didn't have much of this gas in its atmosphere. The first stromatolites might have been formed by diverse types of bacteria that didn't necessarily produce any oxygen, but were just living their peaceful life there. They formed layers, piling on top of one another, so that at least some of them could get a bit of sunlight. They used sand and sticky liquids to stay close together. Brian was also incredibly surprised because those were the biggest living stromatolites he had ever seen. Living stromatolites usually grow to be over 3.3 feet high, but the newly found ones were 15 feet wide and a few feet tall, which is giant compared to those living in other places. And fossilized ones were even larger. A long time ago, they could grow bigger than today because there weren't many other species that could eat or harm them. Also, there are many other organisms today that can grow faster and more massive than them and take up their space. That's why stromatolites can only survive in rare places where hardly anything else can live, like in these very salty lagoons located high above sea level in Puta de Atacama. The stromatolites found there are the most famous ones because they might be some of the best examples of the earliest life on our planet. But they're not actually the first form of life on Earth. The oldest of their fossils are 3.5 billion years old, while some other evidence we have tells us that life on our planet appeared around 4.1 billion years ago. Maybe some stromatolites lived back then as well. But Earth has changed a lot since then, and the places where they might have lived haven't survived. Now, all this may not seem like a lot at first glance, because no one has found an exotic and weird beast our world has never seen. But these are notable examples of what searching for life somewhere else in the universe might look like. Scientists who are interested in studying Mars often come to this place, since it might be similar to what the red planet looked like an exceptionally long time ago. If there were fossils hidden in the ancient rocks on Mars, they might look like these stromatolites. Another faraway land has revealed some of its secrets. It's Antarctica, with an ancient lost world found under its ice. Antarctica hasn't always been this frosty, isolated land of snow and ice sheets. Once it used to be part of the Gondwana Supercontinent, together with what is now South America, Africa, Australia, the Arabian Peninsula, and the Indian subcontinent. But at some point, it split off and went to build a life on its own. It formed as other landmasses started to move away, which created its coastline. But Antarctica was different in many other ways back then too. It used to be a land covered in magnificent forests and rivers full of life. Scientists use radar and satellites to explore a mysterious world hidden under the ice there. This ancient land, which is close to the Indian Ocean, is as big as the U.S. state of Maryland or Belgium. It's more than 14 million years old. Some studies say that this area formed over 34 million years ago, which was way before Antarctica got into its deep freeze. At first, temperatures there were higher, possibly like the weather in Patagonia or the cold, temperate rainforests of Tasmania, New Zealand, or maybe even more tropical than that. But as the climate became cooler, small glaciers started forming on hills close to the rivers. Valleys sunk deeper because of all that ice covering them. And then, temperatures dropped even lower, and a giant layer of ice covered the entire continent, hiding those old glaciers. Rivers shaped this lost world a long time ago, way before it ended up covered in ice that's almost 2 miles thick in some spots. Scientific studies of this area showed that those landscapes had been full of highlands and mountains. The ice that formed over Antarctica made the whole area very cold, so the landscape couldn't erode anymore. This means everything has remained basically the same and untouched under the ice for millions and millions of years. What's interesting is that we know less about this land hidden under the ice than about the surface of Mars. One way to explore it would be to drill through these ice sheets to check for samples of sediments below. They could tell us more about the ancient flora and fauna frozen underneath. It's not a new method. A similar method was used to collect 2-million-year-old samples in Greenland. Australia has a secret world too. Ancient organisms were found hidden in rocks in the northern parts of the continent that are about 1.6 billion years old. These microscopic things are part of a family called eukaryotes. The members of this family that exist today include plants, fungi, animals, and even those tiny organisms with just one cell, such as amoeba. All living things with nuclei in their cells, including us, can trace their family tree back to one of the oldest members of this family. That one is called the last eukaryotic common ancestor, and it lived more than 1.2 billion years ago. Those ancient organisms were more complex and bigger than bacteria. Maybe they were the first predators on Earth, hunting bacteria. Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangaea, or Pangaea if you're feeling fancy. The name comes from a Greek word which means all the earth. Pangaea also had a massive water neighbor called Panthalassa. So our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things change. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangaea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangaea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So how do we know Pangaea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learned their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their four paws. And it's unlikely that this particular type of animal originated in two places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the Supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were two original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figured out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangaea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pangaea joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are four major possibilities: Novo Pangaea, Pangaea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangaea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangaea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So if these secret tunnels will be spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangaea is the most likely scenario. It also depends on what exactly happened to Pangaea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. So keep asking curious questions and stay tuned for the next 100 million years. Well, pack your bags and hurry down to Antarctica, because gold is literally raining from the sky there. $6,000 per day. Well, not exactly from the sky, more like from the eruptions of this massive fiery volcano. The towering beast of a mountain is called Erebus. It looms over the icy, lifeless expanse of Antarctica on Ross Island. It shares the spot with three neighbors, Mount Terror, Mount Bird, and Mount Terra Nova. Although Erebus is certainly dominating the place, it's about 12,500 feet tall, like 8 Empire State Buildings. Now, even though it's far smaller than Mount Everest, it's still the southernmost active volcano in the world. And even though it stands in the middle of nowhere, Erebus is far from lifeless. It has a terrible temper, actually. Erebus constantly breathes and roars, throwing out gases and chunks of molten rock in crazy tantrums called strombolian eruptions. And among them, it spews out tiny, delicate specks of shimmering gold. And it's not a couple here and there. This money fountain works every day, spewing out nearly a quarter pound of gold per day. Like we mentioned, it's worth over $6,000. It also sums up to a crazy 64 pounds of gold per year, over $2 million. But before you treasure hunters rush there, we have to tell you that these are more like particles of gold. They're often less than 60 micrometers in size and are scattered around, impossible to collect. And when we say scattered around, we mean it. Some of those particles have been found as far as 620 miles away from the volcano, carried in the middle of nowhere by Antarctic winds. Now, Erebus isn't a super friendly place to hang out next to. Its eruptions are wild and unpredictable. So, most of what scientists know about Erebus comes from satellites, which monitor its activity from the safety of space. For scientists, this place is also a gold mine. Erebus is the only volcano that can do this stuff. They figured out that this happens when the magma, superhot semi-molten rock beneath the Earth's surface, rises to the volcanoes. Magma brings some liquid gold with it. The moment it meets the chilly Antarctic air, the gold crystallizes into little pieces, and voila, $2 million per year. Erebus is such a weird and rare volcano. Its fiery heart has been burning for over 1 million years. Over these million years, it's been building layer by layer. Its basis is a super ancient lava, and the upper layers are youngsters. And throughout many years, it's been very active, with a glowing lava lake bubbling at its center. This lava lake is exactly what it sounds, a pool of constantly shifting, burning molten rock. This site is incredibly rare because there are only several lakes like that in the entire world. And this isn't just a pool of rock, it's a window into the volcano's soul. In Erebus, it's made of phonolite. Now, phonolite is a very cool rock. Its name comes from the Greek words for sound and stone. Because, guess what? It's a rock that produces a ringing sound when you strike it. There are only a couple of volcanoes that give it to us. But it's not the only volcano that can flex its weirdness. Oldoyenyo Lengai, a volcano from the East African Rift in northern Tanzania, is even more mysterious. It spews what's called nitrocarbonatite lava. Most volcanoes erupt glowing red-hot rivers of molten rock. But this one erupts dark lava. It flows super fast, like water, creating these thin, fast-moving rivers. So all this makes it look almost like black mud or oil. What's even wilder is that as soon as it hits the air, it starts reacting super fast and turns white within hours. It's like magic, with black lava turning into something that looks like white dust or snow. Not even mentioning that it even glows faintly at night. And it's not that hot either. Well, it's still pretty hot, from about 900 to 1,000 degrees Fahrenheit. But usually, lava temperature can vary from 1,300 to 2,200 degrees Fahrenheit. So it's cold by volcanic standards. That's because this lava is rich in some strange soda and salt-like, incredibly rare materials: nererite and gregarite. Nererite is usually colorless and shiny, looking like small clear crystals or plates. Gregarite is often a bit cloudy. These guys are a geochemical mystery. Deep inside this place, there are two pools of magma. The rare minerals are probably born when carbon-rich parts of magma get separated from the rest, forming these two pools. And while they're fascinating, and we can get tons of them from this volcano, they're also completely useless. They're so rare and fragile that they're impossible to use in anything, even jewelry. Still, even astronomers find this curious. If there are planets out there that are rich in carbon instead of oxygen, like Earth, these minerals could be quite popular there. This volcano also releases a lot of gas, and I mean a lot. It's spewing out carbon dioxide at a speed of about 176 pounds per 1 second. Just think about it, about 5 tons of carbon dioxide per minute. Every minute, that's like several cars worth of gas being pumped out into our atmosphere. Luckily, our planet is used to this volcano, so it's not that dangerous to us. Meanwhile, in the central Andes, far from human reach, Lascaria is having the time of its life. This is also one of the most extraordinary and remote volcanoes in the world. This one is even taller than Erebus, rising to almost 18,700 feet. It's surrounded by a barren, otherworldly landscape. There are literally no humans within 90 miles around it, except for some volcanologists. Lastaria is absolutely wild, constantly breathing out hot gases and steam. The air seems almost alive there, shimmering with plumes of vapor escaping from cracks in the ground. These vents, called fumaroles, are more than just hot steam. They're basically chemical labs. They spit out tons of various gases, all of which react with the air and rock around, and what's left behind is something otherworldly. It's like someone spilled a painter's palette, bright yellows, fiery oranges, and rusty reds. But the wildest part are molten sulfur rivers, streams of bright yellow liquid bubbling and flowing down the sides of a volcano. Some of it is still burning, darkening, like some sort of weird s'mores. All that because the sulfur is getting heated to its melting point by the intense heat below and turns into a thick, glowing liquid. Then it starts flowing, cooling, and hardening. You can't tell if you should be fascinated or disgusted by this sight. And if that's not enough to make you feel like you're on another planet, the place itself is just as extreme and crazy. Lastaria is perched high on the Altiplano, at the edge of the Atacama Desert, one of the driest places on Earth. Pretty much no rain, and temperatures can plummet to minus 11 degrees Fahrenheit. At least some volcanic ash enriches the soil, so there are some hardy plants here and there. The weirdest part is a salt pan nicknamed Lake of Sulphur. It's fed by those sulfur rivers. It shimmers with minerals all along its shores. This lake used to be way higher in ancient times, but now it's just a shadow of its former self. Thousands of years ago, it witnessed a catastrophe of unimaginable scale. The southeastern side of the volcano, a huge part of it, crumbled and fell in an instant. The ground just gave way, and an avalanche of volcanic rock and ash thundered down the slopes. The landslide raced at terrifying speeds, faster than the fiercest storm, tearing apart everything in its path. It tumbled for 5 miles. When the dust settled, all that was left was a massive scar about half a mile wide. We learned this story from the debris around the place. Ash, pumice, and lapilli all are the shattered remnants of the volcano itself, lying now at its base.
This area might just be the most important spot in America right now, as it is worth over $1 trillion. There's something incredibly valuable hidden right here at Thacker Pass, and it is going to shake things up, not just in Nevada, but in the US economy and its global relations. The McDermott Caldera is a massive area, about 28 miles long by 22 miles wide, stretching across northern Nevada and southern Oregon. It's in Humboldt County, a quiet, rural place with just one main city that's going to change a lot in the next 5 to 10 years. That's because they found white gold there. We're talking about lithium. And to explain why this metal is so important, we need a scale. On one side, we place a chunk of lithium, and on the other, an apple. What do you think will happen? If both have the same volume, the scale is going to tip toward the apple. That's because lithium is super light. Its density is about 0.3 ounces per cubic inch, which makes it the lightest solid you can find at room temperature. Lithium is also extremely reactive. That means it combines with other elements very easily, and it can catch fire just as easily. Mix it with water, fire. Expose it to air, yep, fire again. But when you combine its lightness with its high reactivity, you get a material that's perfect for batteries, like the one powering your smartphone, laptop, or even your electric car. Nevada's been hiding this treasure for about 16 million years. The McDermott Caldera used to be a volcanic hotspot, spewing molten rock and creating a huge lake filled with mineral-rich waters. Over time, that lake dried up, leaving behind thick layers of clay loaded with lithium. Right now, Thacker Pass Mine is sitting on one of the biggest untapped lithium reserves in the world, worth about $1.5 trillion. If everything goes as planned, they expect it to produce about 40,000 tons of high-quality lithium a year. And that's enough to make batteries for up to 800,000 electric cars. Like I mentioned earlier, this metal is the backbone of modern batteries. And with the world racing toward green energy, the demand for lithium is skyrocketing. Since 2020, its price has gone up more than 10 times, making it the most expensive battery metal in the world. That means it's way more expensive than magnesium, nickel, cobalt, and other materials used in rechargeable batteries. Right now, we're using about 1.16 million tons of lithium per year, and roughly 85% of it goes into making batteries, mostly for cars. Between 2030 and 2040, experts think we will need to double the money we're putting into production, from $94 billion to $188 billion. At the same time, investment in batteries will jump by over 200%, reaching $686 billion. Finally, by 2050, the demand for lithium is expected to be more than 10 times higher than what we're producing now. Sorry, I know that's a lot of numbers, but I just want to show how important Thacker Pass will be for the whole world. This mine is going to be key to keeping everything running. I mean, literally, since most of the future demand will be for things like cars, electric bikes, scooters, and renewable energy storage. Nevada could also be the epicenter of a global energy revolution, with the US aiming to cut pollution by 50% by 2030. A big part of that is replacing gas-powered vehicles with electric ones. And to make that happen, America is going to need a whole lot more lithium than it's producing right now. Nowadays, most of the metal used in the United States come from countries like Chile and Argentina. So if America wants to be a leader in this market, it really needs to invest more and more in projects like Thacker Pass. But there's another challenge. Finding lithium in a mine is one thing, but refining it is another story. Just like diamonds are carefully cut and shaped to bring out their sparkle and sold in rings and necklaces, something similar needs to be done with lithium. The raw material that comes from the mines has to be refined into a pure form that can actually be used in things like batteries. And China pretty much dominates this part of the market, and they're responsible for about 75% of global lithium-ion battery production. In other words, it doesn't matter if a country finds this powerful metal on its land, it will probably still need China to help refine it. So, the US is eager to strengthen its supply chain. In fact, they're so excited about this possibility that authorities have invested over $2 billion in loans into the Nevada project. Because of that, Thacker Pass could make the US a leader in lithium production worldwide. If their estimates are right, the McDermott caldera could hold nearly half of the world's known lithium reserves. It would almost double the reserves found in Bolivia's salt flats, for example, which used to hold the record for the world's largest deposit. This discovery is about to change Humboldt County for good. Those quiet streets surrounded by nature will never feel the same again. The mine will need about 2,000 workers who will probably move there from other cities. Those workers will need houses, hospitals, schools for their kids, and all the necessary services. Do you see how it's like a ripple effect? For every person hired to work on the project during construction, 6 more people will get hired in the state to support them. Thacker Pass is also going to have a huge impact on the economy, not just in Nevada, but all across the country. People expect the mine to be active for 35 years, and each year it's expected to generate over $2 billion. But here's the thing. In Thacker Pass, they'll be extracting lithium from clay, and this process has never been done on such a huge scale before. So it's kind of a hit or miss. But if it works, it could completely change the industry. Big question. Who's interested in all this? Well, we've got 3 big companies eyeing the lithium market in the US. First, there's ExxonMobil. The oil giant wants to start producing lithium by 2027, and they have plans to become the top supplier for electric vehicles by 2030. Then there's General Motors, the company behind big car brands like Chevrolet and Cadillac. They're so interested in this business that they agreed to pay $625 million for a 38% stake in Thacker Pass. And finally, Tesla. In 2023, they started building a factory in Texas to process lithium. It's all part of their plan to handle more of their supply chain themselves. Now that you know how important lithium is, you might be wondering, what if we run out? Well, that could happen, since it comes from mining and, just like gold, is a finite resource. But that doesn't mean we'd have to give up smartphones or electric cars. If we ever run out of this metal, we'd probably find new ways to produce batteries. In fact, some experts think thermal batteries could be the next big thing. They store extra energy from renewable resources like wind or solar power, which are very cheap. So they represent a new way of storing energy at a small fraction of the cost. Nowadays, they're primarily used for powering the production of steel, cement, and chemicals. Thermal batteries are also being used to heat and cool large buildings. However, more and more projects are focusing on bringing this technology into private spaces, like houses and apartments. Experts are optimistic that initiatives like these could make thermal batteries as well known as electric batteries, and they might soon become a regular part of our daily lives.
July 17, 1998. It started like a usual quiet evening in the villages along the north coast of Papua New Guinea. Then, at 5:49 p.m., the ground shook violently. Suddenly, a 7.0 magnitude earthquake struck. It sent shockwaves through the region. Walls cracked, homes trembled, and the earth beneath the villagers' feet shifted and twisted. It lasted for 19 seconds, with a depth of 19 miles, and seemed like a typical earthquake. And while it caused some damage, this wasn't the kind of destruction that screamed doom. So, people were tricked. They thought it was over. They didn't know that the worst was still coming. Then some villagers noticed mysterious lights. It began with a flash of red light along the horizon, a streak that looked like fire. It appeared shortly after the initial earthquake, stretching across the northern sky above the ocean. It flared brilliantly, then vanished in an instant. What could it have been? People started speculating whether it's a warning about something or just sunlight reflecting strangely. But just as it disappeared, it was followed by a loud booming sound from the sea. No one knew what that meant, and some villagers went to the beach, curious to scan the views. What they noticed there chilled them to their core. The ocean looked wrong. The water wasn't calm. It churned, bubbled, and boiled in an eerie, unnatural way. That's when they saw it. A massive wave building in the distance, rushing toward them with terrifying speed. Panic spread like wildfire. People climbed trees, pushed boats into the lagoon, hoping to escape the approaching monster. Unfortunately, it was too late. The first wave hit with unimaginable force and swept away entire villages in an instant. The debris was scattered around, trees were uprooted, buildings were displaced up to 160 to 200 feet inland. Even decades later, some of these affected villages can't be accessed by roads. At the same time, another strange phenomenon emerged. Many people described a red glow at the crest of the tsunami, as though the wave carried fire in its peak. They described an eerie glow as the wave approached the shoreline, a deep and unearthly hue, visible even from far-off places like Itape. And this was only the beginning. 2 more waves followed in quick succession. The second one was the most horrifying, from 33 to almost 50 feet high. By the time the ocean finally receded, the coastline was unrecognizable. After the waves had ravaged everything, leaving villages in ruins, the sky put on one final display. Survivors described a yellow or yellow-red glow illuminating the sky over the ocean. One man who survived by climbing up a tree saw the glow lingering over the horizon, stretching toward the direction of Arap and Itape. At Malol, the Sisters of the Mission looked out to the sea and were stunned by the surreal calm of the golden water. It was still as glass and lit by this unearthly glow. The glow was so vivid, It lit up the entire devastated landscape. Luckily, this allowed survivors to begin searching for their missing loved ones. A lot of people believe these lights were supernatural, an omen of sorts. This event ended up being catastrophic, sudden, and unpredictable. The Royal Australian Air Force responded immediately, sending in planes with relief supplies. People started an investigation. What exactly caused this disaster? Turns out, this tsunami wasn't like most others. Tsunami waves are very different from regular ones. We usually imagine huge breaking waves next to the beach. But they might first look like the water is rushing away from the shore. Stay vigilant because this is a warning sign. The water will come back very quickly and rise like a massive tide, often with devastating force. Rarely they come alone. They often arrive in a series, destroying everything along the coastline. They happen when a large amount of water in the ocean or big lake gets suddenly pushed out of place. The main causes are usually earthquakes, which happen when the Earth's tectonic plates shift suddenly under the ocean. They start lifting or lowering the seafloor, and this pushes the water above it, causing huge waves. This tsunami in Papua New Guinea was completely different though. At first, scientists thought that it was caused by the Australian and Pacific tectonic plates slipping against each other. But it turned out that the earthquake itself wasn't the problem. It really was pretty small. However, it had triggered a massive underwater landslide. When the seabed shifted, it pushed away an insane volume of water. The waves reached almost 50 feet high, like a 4-story building. That's how we realized that even small earthquakes can actually cause massive tsunamis via underwater landslides. What's even worse is that tsunamis like this can happen with little or no warning, simply because the earthquake alarms don't go off. But what about that bubbling and boiling of water that people saw? Turns out, this was the release of underwater gases. Beneath the ocean floor, there are pockets of gas trapped in the sediments. For example, methane, which is often found in oil and gas fields, or hydrogen sulfide, a gas that smells like rotten eggs. During the earthquake, the seabed probably cracked or shifted, releasing these gases into the water. This caused bubbling or boiling. The water might have heated in some areas. People mentioned that the waves felt hot and even stung their skin. The chemicals in it most likely made things even worse, irritating their skin. These gas eruptions might also have played a role in making the tsunami stronger. Maybe they were the ones that loosened the sediments that caused the underwater landslide, or pushed the water up when the gas escaped. It's like shaking up a bottle of soda. If the pressure releases suddenly, it causes a huge reaction. But what about the strange lights? Well, that's more complicated. There's a phenomenon called earthquake lights. They happen all around the world, flashes, glows, or aurora-like effects. Although they're usually white, bluish, or even multicolored, sometimes these lights last seconds, sometimes up to tens of minutes, at any point in an earthquake. If we go by their description, then the first red flash could have happened because of electricity. Earth's crust is full of quartz and similar stuff that can release electricity under pressure. When the earthquake shook the ground, all that electricity traveled up into the air. Gases from before could have helped here. They could ignite or interact with charged particles in the air, making the lights even brighter. As the wave continued to churn up sand, rocks, and debris, the intense pressure and movement could have released more sparks. This could cause the fire-like lights at the wave's crest that people noticed. Finally, the yellow light could have been all these electricized gases rising into the atmosphere. Methane and other gases interacted with Earth's magnetic field and created something like aurora borealis. But these are all speculations. The most heartbreaking part of the story is that tragedy in Papua New Guinea was preventable. Scientists knew the tsunami was coming, though it arrived earlier than they expected. The first wave struck between 10 and 25 minutes after the earthquake, about 5 minutes earlier than models showed. That means that it started somewhere close to the shore. The reason no one evacuated in time was simple. Local people didn't have a tsunami warning system or even enough knowledge about tsunamis to understand that an earthquake might lead to one, or why the water was acting weird. Things like that haven't happened in Papua New Guinea in over 60 years. But this was a wake-up call. From this immense tragedy came lessons and resilience. A year after the disaster, all the surviving locals watched a documentary that explained what had happened and taught them what to do if it ever happened again. This effort saved lives because the story did happen again. A similar earthquake and tsunami struck the nearby island of Vanuatu in November 1999. But this time, the villagers were ready. They remembered what they had seen in the film. Instead of panic, they acted quickly, and luckily, hundreds of lives were saved. Now, tsunami warning systems are everywhere in developed areas. They can send alerts to people via sirens, text messages, or broadcasts as soon as a potential tsunami is detected.
A bridge, a very helpful structure that traces back to the Neolithic times. The oldest bridge in the world, at least the one that is still standing, is the Arcadico Bridge, built more than 3,000 years ago. But there's a river you cannot cross using a bridge: the Amazon River, the largest and longest river in the world. Okay, the Nile River is actually the longest river in the world, but the Amazon wants both titles for itself. The Amazon River is born in Peru and crosses Colombia and Brazil until it reaches a massive delta at the Atlantic Ocean. Its waters travel a longer distance than Frodo and Sam, and yet not a single bridge has ever been built over it. Why is that? First of all, seasonal floods change the size of the river. During dry seasons, the Amazon is about 3 miles wide, but during heavy rains, it can get up to 30 miles wide in a few weeks. Not only that, but the flood also makes the river change its position. Now imagine trying to build a bridge in a place where the ground turns into water for about 4 months. Not an impossible task, but not the easiest one either. Now, if you look back at your geography classes, you might remember that the soil of the riverbank can be very soft, especially in the Amazon, which means it can erode and shift. Heavy rains also create marshes, a type of wetlands that actually reduces the magnitude of the floods and purifies the water. It's also home to many animals. This means that to build a bridge, part of this wetland would have to be drained, which would ruin the lives of all those animals. Besides, the foundations of said bridge would have to be deep, and that would cost a lot of money. The rain creates yet another problem for the potential bridge. It increases the river's water level by 13 to almost 50 feet. Of course, bridges have been built in deep rivers before, like the Padma Bridge, a gigantic structure with a foundation of 417 feet. But because the soil of the Amazon River can erode easily, a bridge would have to be built using floating structures, known as pontoons, and they're not helpful in a river that changes depth whenever it feels like it. Next on our list of things that are a problem to human endeavors is the Amazon rainforest. This forest spreads over 9 countries and is so big and so dense it could cover about half of Europe. This means that a bridge would almost likely connect one patch of the forest to another. A pointless improvement to the lives of capybaras and jaguars. Of course, the real users of such a bridge would be humans. Most people live around the tributaries of the Amazon River, not around the river itself, because who wants to live like a beaver at a dam? There's even a state called Amapá on the left side of the Amazon River that is completely cut off from the rest of Brazil. You could easily take your car and visit its neighbor, a place called French Guiana. But if you wanted to go to another part of Brazil, you'd have to find other means of transportation. Aside from small riverside populations that live right on the riverside, of the Amazon, bigger cities were built near tributary rivers, like the Rio Negro, which has a bridge, by the way, and the Nanay River in Peru. The bridges that go over the Nanai and the Rio Negro are the only two bridges over the rivers in the Amazon basin. The lack of good roads and highways inside the Amazon also makes the creation of bridges a pointless endeavor. Back in the 70s, humans had big ideas on how to explore the Amazon ever more, which is why they decided to build a highway which would cut the Amazon basin from left to right. The road, called the Trans-Amazonian Highway, was supposed to bring people to the heart of the Amazon. But it seems like the difficulties of building more than 2,000 miles of road inside a dense rainforest were not foreseen. Halfway through, the project was abandoned because it was super expensive and problematic. Nowadays, highways in the Amazon basin are always flooded, filled with holes and mud. This whole situation creates a ripple effect. People don't live near the river because it's hard to access it. The roads don't go there either, because it's hard to build them. Which in turn makes even fewer people want to settle on the banks of the Amazon River, because they have no roads to get them there. So, if there are no roads and no bridges, how do people live there? You're not gonna believe this, but the riverside population uses a very old but reliable invention called a boat. The Amazon River is fully navigable, and the people that live there use it like a road. Much like motorcycles, cars, and buses, the Amazon River has canoes, speedboats, and ferries. There's even a very specific ferry called Obidense, transporting people to the municipality of Obidos, hence the name. Locals do everything on boats. They even have a boat hospital that floats around and visits riverside populations, and a boat bank, so you can do all your bank-related things while looking at the vastness of the Amazon. Honestly, genius invention. The downside to this lack of bridges is that it stops us from exploring the truly hidden gems of the world. In the Amazon, for example, there are over 10,000 undiscovered archaeological sites. We may never be able to dig out stuff like fortified villages, geoglyphs, and many other structures. It would be pretty neat to go full-on Lara Croft in the middle of the Amazon, but these findings are tucked deep in the heart of the forest. At the same time, only on a boat are you able to witness the crazy phenomenon of the unmixed waters of the Rio Negro and the Solimões on the Amazon River. For more than 3 miles, these two tributaries of the Amazon River flow side by side without mixing. The speed and the temperature of these waters are different, so you'll see a river that looks like coffee and Coca-Cola mixed. This awesome phenomenon is called the meeting of waters. But the Amazon River is not the only river in the world deemed bridgeless. The Congo River, the second longest river in Africa, only has one bridge crossing it. The two Congos, yes, there are 2 different countries in the world named Congo, are separated by the Congo River, and so far, no roads connect them. Also, fun fact, some geologists believe that back when Gondwana existed and the continents were all cuddled together, the Amazon and the Congo River were one river connected to each other. Another place with a lack of bridges is the east side of the Thames in London. The west side of the river is narrower, which makes building a bridge easier. There are about 33 bridges on the west side alone, but if you want to cross the river from the east side, it's gonna be a hassle. The thing is, back in the 1800s, shipping companies decided that building too many bridges over the Thames was too expensive, because this was a shipping route and the bridges would have to be taller than usual. The structure would also have to be long, since some parts of the Thames are about 1,870 feet wide. But building long bridges is not a problem per se. In Rio de Janeiro, for example, you can find the Rio Niterói Bridge, which is about 8.26 miles long. Back when it was built in the 70s, it was the second longest bridge in the world. The bridge is so long that in 2018, a girl was born while her mother was crossing it, and now the birthplace in her birth certificate is literally the bridge. There's also no U-turn on it, so if you drive onto the bridge by mistake, you're in for a long drive. So next time you feel like exploring the Amazon, remember to pack your own boat. Scientists discovered the largest water reservoir in the Oregon Cascades. It's hiding underground, holding more than twice the water volume of Lake Mead. Let me specify. It contains at least 19.4 cubic miles of water, which is almost 162 trillion bottles of water. If you drank 1 bottle a day, it would take you around 444 billion years to finish your stock. No wonder this underground aquifer discovery is so awesome. The Cascade Mountain Range, which contains the largest aquifer on Earth, stretches about 700 miles from Northern California to British Columbia. The high Cascades in Oregon have younger volcanic rocks, around 8 million years old. The Western Cascades are much older, 45 million years. They boast deep canyons and valleys. Scientists study the transition zone between these two areas to understand how water moved through volcanic rock and how volcanic processes had evolved over time. In the process, researchers measured rock temperatures at different depths. That's when the underground aquifer discovery happened. Normally, deeper rocks should be hotter because it's closer to the Earth's interior. But, to everyone's surprise, in several areas, the temperature stayed the same even at greater depths. Well, this was a strong clue that water was flowing through the rock and cooling it down. In other words, the Cascades function like a natural water tower, storing and slowly releasing water into rivers and streams. These geological water findings are important for two main reasons. First, it's our potential water source for the future. Such a massive amount of water stored underground could be an important resource. So far, we don't know how long it will remain in its current state and how resilient it's going to be to changes. So, we need more research to properly manage its use. Secondly, it affects volcanic activity. When water seeps deep underground and reaches magma, it instantly turns into steam, creating extreme pressure that can trigger explosive volcanic eruptions. Understanding how much water is stored in volcanic rock could help predict future eruptions and the risks they pose. Now, even though this discovery is exciting, there are still many unanswered questions. Like, how does this water move through the volcanic rock? Or how much of it is actually usable as a water resource? Since this underground reservoir depends on rain and snow, a series of dry years could cause big problems for both water supply and volcanic stability. Researchers are now working to understand the full impact of the Cascades volcanic water reservoir and how to manage it responsibly. But let's look closely at the geological wonder that is the Cascade Range. Picture this: a massive mountain range stretching all the way from Northern California up to British Columbia, cutting right through the middle of Oregon. That's the mountain range we're talking about. In Oregon alone, it's about 260 miles long and up to 90 miles wide, covering 17,000 square miles. Whoa, that's bigger than each of the 9 smallest US states. The coolest thing is that the Oregon part of this mountain range is basically built by volcanoes, and apparently contains at least one volcanic rock water storage. The range itself exists because of something called the Cascadia Subduction Zone, where the Juan de Fuca tectonic plate, a chunk of Earth's crust under the Pacific Ocean, is slowly getting shoved beneath North America. As it sinks, the intense heat and pressure force water out of the oceanic rock. It lowers the melting point of the surrounding mantle and creates magma. That magma rises up and fuels the Cascade volcanoes. This is part of the Ring of Fire, the giant belt of volcanoes circling the Pacific. So, in a way, the Cascades are part of a much bigger volcanic system that's constantly shifting and changing. The Oregon Cascades are actually made up of 2 completely different zones, the Western Cascades and the High Cascades, and they look nothing alike. The Western Cascades are the older part. They formed around 45 million years ago. These mountains are rugged and deeply carved up by rivers. Some canyons are as deep as 3,700 feet. This part of the range used to be volcanically active, but over time, erosion has taken over, reshaping the land. The High Cascades, on the other hand, are much younger and way less eroded. Around 8 million years ago, the volcanic activity shifted, and new eruptions filled in old canyons, smoothing out the landscape. Eruptions kept piling up fresh lava, and rivers in this region didn't have as much time to create deep valleys like they did in the Western Cascades. That's why if you look at the two regions side by side, one looks jagged and carved up, while the other looks smoother and more built up. Some of Oregon's most famous volcanoes are located in the high Cascades. I'm talking about Mount Hood, Mount Jefferson, the Three Sisters, and Crater Lake, which actually formed when Mount Mazama erupted and collapsed in on itself. Unlike smaller volcanoes that pop up, erupt for a bit, and disappear over a few months or years, these giant volcanic centers have been active for thousands of years. And because they've been around for so long, they have way more complex magma systems. They produce everything from basalt, which is a runny, fast-moving lava, to andesite, dacite, and rhyolite. And rhyolite is the type of magma that leads to huge explosive eruptions. So while some of these volcanoes might just ooze lava, others have the potential for devastating blasts. Another amazing thing about these long-lived volcanoes is that their underground magma chambers stay hot for a really long time. That's why the Cascades are one of the best places to tap into geothermal energy. There's a ton of heat just sitting beneath the surface, waiting to be used. Oh, and don't forget about the Cascades volcanic water reservoir. Who knows how we will use it in the future? Now, we already know that the Cascades are part of the magnificent Ring of Fire, Earth's most explosive zone. Imagine a massive horseshoe-shaped belt wrapping around the Pacific Ocean, stretching for about 25,000 miles. It's one of the most geologically active areas on the planet. This is where Earth's tectonic plates are constantly shifting, colliding, and grinding against each other, creating some of the world's most powerful earthquakes, volcanic eruptions, and deep ocean trenches. The Ring of Fire follows the meeting points of multiple tectonic plates, and they all surround the giant Pacific Plate. These plates aren't just sitting still, they're always on the move, pushing against or sliding beneath each other at their boundaries, known as fault lines. When this happens, you get everything from deep-sea trenches to towering volcanoes and violent earthquakes. One of the most extreme examples of this activity is the Mariana Trench, located east of Guam. At 7 miles deep, it's the deepest ocean trench on Earth. It was formed by a process called subduction, where one tectonic plate is forced beneath another, sinking deep into the Earth's mantle. The Mariana Trench is one of the most mysterious places on Earth. It's insanely deep, with crushing pressure and total darkness. So for a long time, people thought nothing could live down there. But it turned out that life existed even at the very bottom. In 2005, scientists found a tiny single-celled organism in the Challenger Deep, the deepest part of the Mariana Trench. They also came across colorful rocky formations and weird sea cucumbers. The Mariana Trench also has hydrothermal vents, which are basically underwater hot springs. Even though the water there is super hot and acidic, strange creatures and microscopic life forms still manage to survive there. The Ring of Fire is also responsible for 90% of the world's earthquakes. Some of the most powerful quakes in history have happened here, including the 1960 Valdivia earthquake in Chile, the strongest ever recorded, which hit a mind-boggling 9.5 on the Richter scale. But it's not just about earthquakes. The Ring of Fire is also home to about 75% of the planet's volcanoes. Some of the most famous eruptions in history have come from this region, like the infamous Mount Tambora in Indonesia. In short, the Ring of Fire is one of the most dangerous places on Earth, but it's also incredibly fascinating. Who knows what else scientists might discover in that region, like they discovered the largest water reservoir in the Cascades.
Uranus is an enigmatic giant that has puzzled astronomers for centuries. But what sets this gas giant apart from the others is its strange tilt. While most planets spin on an axis that is perpendicular to their orbit, Uranus takes a wild spin in a different direction. But why does it look like this? How did the planet turn out to be lying on its side? And what would we see if we visited the surface of such a planet? Let's find out. Uranus, the seventh planet from the Sun, is a cosmic oddball and source of many jokes. It's one of the gas giants in our solar system, along with Jupiter, Saturn, and Neptune. It's also the third largest planet in our solar system, with a diameter of about 31,000 miles. And one of its many oddities is a weird rotation on its side. Not all planets in our solar system are aligned in a straight line. While most planets in our solar system have an axial tilt of less than 30 degrees, Uranus is tilted at an angle of almost 98 degrees. It's like that one friend who always has to be different, even if it means standing on their head to prove a point. So its north and south poles are facing east and west. It's like the planet got lazy and just rolled over one day, deciding to take a nap. And why is Uranus so tilted, you ask? Scientists once thought this was due to some kind of collision. They thought that something gigantic crashed into Uranus, something like what happened to our Earth. A dwarf planet crashed into it, the Earth tilted slightly, and the Moon was born from the remnants of the collision. But this theory had a problem. In the early universe, there were a bunch of asteroids, dwarf planets, and other large objects. And if this is so, then why is only Uranus tilted? All sorts of guys have crashed into other planets too, but they don't have such features. But recently, scientists have published a new study, and now scientists think that the culprit might be a long-lost moon that wandered away. Back in the days of the early solar system, the giant planets partied much closer together and way closer to the sun. But, as we all know, parties can get out of hand. Something caused Uranus and Neptune to migrate the farthest, like they were trying to get away from the sun's strict supervision. Each giant planet had a collection of moons, but they were constantly getting shuffled around during all this migration madness. Some planets lost moons, while others gained new ones. Uranus could have been born with a massive moon, or quickly captured one, and if that moon was big enough, it could have started playing games with Uranus's spin. This moon pulled on Uranus with its gravity, making the wobbling even worse. As time went on, it made Uranus tilt more and more. Eventually, it crashed into the planet, locking it into its current tilt. While the theory is pretty sound, based on computer models, we'll have to wait until at least 2030. That's when China plans to launch the Tianwen-4 spacecraft to take a closer look at Uranus and study it more. Who knows what other crazy space secrets we'll uncover next? Until then, we can all have a good laugh about the lazy, rebel planet that just can't seem to stand up straight. Such a funny and unique feature makes you wonder, what exactly would we see if we were standing on this planet? How would its strange tilt affect the view from its surface? Let's see, if you were standing on the surface of Uranus, although it doesn't really have a surface, it's more like a gas atmosphere, you'd enjoy a cool view. You'd see the sun rise in the east, just like on Earth, but then it would keep going around the sky in a tilted path, like a lazy spiral. About the sunset though, I hope you have some patience, because it would take 42 years for the sun to complete one full circle around Uranus's sky. That's a really long time to wait before finally going to bed. But speaking of the sky, it would be a beautiful sight to behold. Uranus is known for its stunning, unique blue-green color. It's caused by the methane gas in its atmosphere. Methane absorbs red light, giving Uranus its cold hue. You'd also see some amazing clouds and storms swirling around the planet. But if you're looking for constellations, you're out of luck. The extreme tilt of Uranus means that its poles face towards the sun, so the stars would be all over the place in the sky. The constellations that are familiar to us would be unrecognizable from Uranus. Also, as the planet rotates, the position of the stars would change very often. For you sailors out there, good luck in navigation. But you could see its beautiful moons. Uranus has 27 known moons, with the largest being Titania, followed by Oberon, Umbriel, Ariel, and Miranda. These moons are thought to have formed from the same material that formed Uranus, and yes, the tilt affects them too. They orbit around the planet perpendicular to the planet's motion around the sun. And they aren't the only ones. Did you know that Uranus also has rings? Yeah, not only Saturn is so special. The rings are made up of ice particles, some as small as grains of sand, and others as large as several feet across. They're thin, narrow, and dark compared to Saturn, for example. They're actually so black that they almost don't reflect the light. That's why it's so difficult to see them from Earth. But if you were near the surface of Uranus, you might be able to see them in the sky. The only question is, would you even be able to focus on all these views? Because Uranus is extremely cold, and that will probably be the only thing you'd think about. We're talking about temperatures that can drop down to negative 350 degrees Fahrenheit. Brr, better pack some warm clothes for this trip. This is because it's so far from the sun, and its atmosphere is composed mainly of hydrogen and helium. And not only is Uranus the coldest planet in our solar system, but the winters there are long. Due to the extreme tilt, it has seasons that last for over 20 years. It's like the planet is stuck in a perpetual state of winter, which is both cool, pun intended, and kind of sad at the same time. And if that's not cold enough, Uranus is also known for its strong winds. In fact, they can blow up to 360 miles per hour. So you might want to hold on tight to something, or wear a windproof suit to avoid being blown away like a leaf. And finally, Uranus's magnetic field is also tilted at an angle of 59 degrees from the planet's axis of rotation. This creates some interesting effects. The most obvious one is beautiful auroras, which are similar to the northern and southern lights on Earth. On Uranus, however, the auroras are located near the planet's equator rather than at the poles. Isn't that cool? The result is a dazzling light show that would make even the most jaded space traveler stop and stare in wonder. But even though it sounds pretty awesome, it makes it more difficult for spacecraft to navigate around Uranus. The magnetic field creates a lopsided gravitational pull that can affect the trajectory of spacecraft. This makes exploring Uranus a bit more challenging, but maybe it will change in the future. All in all, standing on Uranus would be a chilly, wobbly, and breathtaking experience, and definitely not your average stroll in the park. Next time you look up at the night sky, think of this beautiful icy planet, and remember that even in the vast expanse of space, there is always something new and exciting to discover.
We all know that space missions come with a hefty price tag. To break it down, a ticket to space for an astronaut starts at around $20 million and can soar up to $50 million. NASA may be a well-funded organization, but you can bet they're always on the lookout to cut costs and save millions wherever they can. Plus, NASA has long realized they do not need to go to Saturn's moon to study if there's life there. We already have the suitable conditions for extraterrestrial life in Wyoming. If that resonates with you, then you already understand why NASA is so interested in Yellowstone. To explore life beyond Earth, we need to study environments that mimic extraterrestrial conditions. That's where all those hot springs come into play. Now, it's not the entire park that piques NASA's interest. Let's leave the bears, moose, and other Earthlings to our local biologists. The real hotspot is the geysers, where microbial life flourishes. Oh, by the way, Yellowstone has more geysers and hot springs than the rest of the world combined. In some of them, water can reach temperatures as high as 192 degrees Fahrenheit. You might think, hey, that's only good for steeping tea. But here's the thing. Life in the form of microbes not only survives but thrives in these extreme conditions. having adapted specifically to them. So, could these microbes help us find life on other planets? Absolutely. Now, let's shine the spotlight on the real superstar, the Grand Prismatic Spring. It's packed with silica, which gives it that stunning color. Silica reflects sunlight, especially the blue wavelengths, which is why it looks so vibrant. The coolest part, though, is not the color, but the fact that this spring can teach us a lot about how life evolved. Way back around 4.5 billion years ago, I wasn't around then, living things didn't know how to harness energy from sunlight yet, so they were using chemical processes instead, just like they do now at the Grand Prismatic Spring. But why are we talking about other planets? Well, if life on Earth kicked off in a comparable way to what we see in Yellowstone, there's a good chance we could find something similar elsewhere in the universe. And if we could nail down exactly how life started here, we could really fine-tune our search for life on other planets. Geysers, very similar to those in Yellowstone, can be found on moons like Enceladus, which orbits Saturn, and Triton, which is a moon of Neptune. But how do they compare to the geysers we see in Yellowstone? Well, back in 1989, NASA's Voyager 2 spacecraft made a groundbreaking discovery when it spotted geysers on Triton. This was the first time anyone had seen a geyser outside of Earth, not counting the volcanic eruptions on Jupiter's moon, Io, that were found by Voyager 1 in 1979. Since then, more geysers have been found on other moons in our solar system. In Yellowstone, geysers are heated by hot water from deep within the Earth. However, geysers on some of the outer moons get their heat from tidal forces, the gravitational pull from the big planets they orbit. You know how ocean tides on Earth are affected by the moon and the sun? Well, these moons experience something similar, but on a much larger scale. Beneath the icy surfaces of these moons are warm, salty oceans that stay liquid because the thick ice above keeps them insulated. As the moons move closer and further from their parent planets, the constant tugging creates heat, causing the warm water below to shoot out into space whenever there's a crack in the ice. This icy crust and the warm water underneath are a bit like a frozen pond on Earth. But could there be life swimming around in these hidden oceans, just like there are critters thriving beneath the ice of a pond? That's something scientists want to find out. NASA hopes to send advanced spacecraft to explore these distant moons and look for signs of life. But those warm oceans are buried miles beneath the frozen surface. So, how do we reach them? The answer may lie in geysers. In February 2019, a group of planetary scientists decided to visit Yellowstone in the winter to study the similarities between Earth's geysers and those in space. They know that Yellowstone's geysers are home to some tough little microbes called extremophiles, which thrive in extreme conditions like hot or acidic water. The researchers wanted to learn as much as they could about these microbes and the environments they live in. They brought along a bunch of scientific tools to measure things like temperature, pH levels, and oxygen in the water. They also used special instruments to analyze the chemicals in the ice and rocks and sniff the air for gases. Plus, they collected samples of rock, ice, and water from the geysers, catching tiny droplets on sheets of foil coated in geyser spray. Their main target was the Great Fountain Geyser in Yellowstone's Midway Geyser Basin, which puts on a spectacular show 2 to 3 times a day. However, visiting in winter posed some challenges. Some scientists were delayed by snowy weather, arriving late at night right before they were supposed to enter the park. Then their SUV got stuck in a snowdrift and had to be rescued by a snowplow. The next day, riding in a snow coach, the team had to trudge through deep snow for nearly a mile to reach the geyser, keeping an eye out for elk, bison, and even bears. As they made their way to the Great Fountain Geyser, they took breaks to gather samples and measurements from other interesting pools along the way, like Lemon Pool and Surprise Pool. Even though Yellowstone feels remote, it's not nearly as far away as places like Enceladus and Triton. It's a unique natural laboratory that can teach us a lot about life on Earth and potentially beyond. Oh, as for labs, the Great Prismatic Spring may count as one. Look at these guys. Under the microscope, they look like matches. Their official Latin name is Thermus aquaticus. They live in this hot spring, and these bacteria have saved millions of people's lives. Now, if you're skeptical about what I just said, then you need to know that these bacteria help to create the basis of PCR tests widely used in today's medicine to give fast and precise diagnosis. Back in the 60s, a microbiologist named Thomas Brock was exploring the park's superheated thermal pools and stumbled upon something amazing. Brock was super interested in bacteria that could thrive in extreme conditions. During his 10-year journey studying geysers and thermal springs, he found a microbe in a spring called mushroom pool that could survive in nearly boiling water. This little guy, Thermus aquaticus, turned out to be a game changer for science. Why? Well, it's crucial for a technique called PCR, also known as polymerase chain reaction, which is used to quickly make copies of DNA samples. Before Brock's discovery, this process was tricky because the heat could damage the enzymes that hold DNA together. But thanks to Thermus aquaticus, scientists could now heat and cool DNA samples without breaking them down, making everything faster and easier. It all happened because researchers had purified an enzyme called tag polymerase out of this organism. Those Yellowstone microbes could also be your new go-to for a delicious and sustainable breakfast. A unique microbe was discovered there during some NASA-funded research, and it's now being transformed into tasty vegan breakfast patties and cream cheese. Originally found in a hot spring, this little wonder is called Fusarium strange flavolapsus, and it caught the attention of space enthusiasts as a powerful protein source for long space missions. Plus, it requires way less water and land than beef, making it a smart choice for the planet. Researchers initially looked at this microbe for biofuel, but soon realized it could be cultivated into a complete protein with a texture reminiscent of chicken. Marked as FY, it can be turned into a variety of food products, all thanks to a fermentation process that keeps it free from contaminants. Oh, almost forgot. NASA is even working on a bioreactor to grow FY in space. Ooh, stay tuned.
Doctor, I can't understand what's going on. I feel dizzy and, how do I say it? I'm tilting. It didn't happen overnight. Like, I didn't wake up and couldn't stand straight. No, one day, I felt that my axis had shifted by 1 inch. Another day, it was 2 inches. And once, you won't believe it, it was 31.5 inches. That's alarming. What if I accidentally turned upside down and all my inhabitants fall off my surface? Ah, dear Earth. We ran some tests and are ready to explain an unfortunate combination of factors that has affected your axis. The last one will perhaps be the most unexpected and upsetting. It all started back in March 2011, when a devastating magnitude 9 earthquake struck off the coast of Japan. It was so powerful that not only did it shift Earth's axis, but it also shortened the length of the day. This earthquake displaced our planet's axis by approximately 6.5 inches and may have moved Japan's main island by about 8 feet. Like other similarly massive earthquakes, it also altered Earth's rotation speed. To make it easier, let's compare it to a spinning ice skater. When a skater pulls their arms close to their body, they spin faster by concentrating their mass near the axis of rotation. Something similar happens during the most powerful earthquakes. They shift Earth's mass closer to its rotational axis, causing it to spin faster and shortening the day length. The calculations showed that the Japanese earthquake sped up Earth's rotation by about 1.8 microseconds, which is about 1.8 millionths of a second. Not a big deal, but at the end of the day, every nanosecond counts. For comparison, the infamous Indonesian earthquake shortened the length of a day by 2.68 microseconds. It struck on December 26, 2004, at 0:58 UTC. The epicenter lay off the western coast of northern Sumatra, Indonesia. This powerful undersea earthquake triggered devastating tsunamis that swept across the Indian Ocean, causing widespread destruction and immense loss of life in countries like Indonesia, Sri Lanka, India, and Thailand. Even coastal areas as far as East Africa had severe damage. The Earth's magnitude, initially recorded at 9.0 on the Richter scale, was later adjusted to between 9.1 and 9.3, making it the most powerful earthquake ever recorded in Asia. The faulting, that's when Earth's crust completely breaks and its parts slide past each other, lasted between 500 and 600 seconds, and it was the longest duration ever observed. The immense force of the quake caused the entire planet to vibrate by at least half an inch and triggered other earthquakes as far away as Alaska. All that immense energy the earthquake released caused subtle but quite measurable changes to Earth. The shift in mass slightly changed the planet's rotation, shortening the day. It also caused a small wobble in Earth's axis from 1 to 2.4 inches toward 145° east longitude. So, when it comes to changes in Earth's rotation speed and axis, it's all about the redistribution of mass. This can happen naturally through disasters, but human activities can also trigger it. Take the Three Gorges Dam, for instance. This massive structure across the Yangtze River in China's Hubei province may seem to be an engineering triumph, but it's pretty ambiguous. Finished in 2012 after nearly 20 years, this massive dam is 7,660 feet long and 607 feet high. And yes, it is so big that it can affect the way our planet spins. Its reservoir is capable of holding 9.5 cubic miles of water, has enough mass to slightly alter the Earth's rotational inertia, slightly slowing the planet's rotation. According to NASA, the Three Gorges Dam reservoir could shift Earth's pole position by almost 1 inch and increase the length of a day by 0.06 microseconds. Dams aren't the only worry. If polar ice melts, water rushes into the oceans, hiking up sea levels, especially near the equator. This mass shift slows Earth's spin way more than dams do. You won't feel it day to day, but it can affect ultra-precise equipment, such as atomic clocks. To fix this, scientists suggested a negative leap second, making a minute 59 seconds, to balance Earth's spin changes. Okay, so you're thinking you've got nothing to do with all those tilts. You don't build dams, right? Bad news. If you take regular showers, you're part of it too. Every time you turn on the tap, you're affecting Earth's tilt just a tiny bit. Thing is, our planet is always shifting and adapting, so even small actions like using water can influence its orientation. Over the past 2 decades, groundwater pumping has caused the Earth's tilt to shift by 31.5 inches. This water redistribution is equal to about 0.24 inches of sea level rise. It turns out that among climate-related causes, groundwater redistribution has the largest impact on the drift of Earth's rotational pull. But what is groundwater? It's the water stored beneath the Earth's surface, filling the spaces in soil, sand, and rock. It comes from rain and other precipitation that seeps into the ground, collecting in underground reservoirs, aquifers. Unlike rivers and lakes, groundwater stays below the surface, acting like a natural water reserve. Thanks to it, we have a steady supply even during dry periods. Many people, especially in rural areas, rely on groundwater as their main source of drinking water. Farmers use it to irrigate crops, while industries depend on it for manufacturing and cooling systems. It sounds pretty harmless, doesn't it? How can something so useful cause our planet to shift? Well, a study covering data from 1993 to 2010 revealed that we've pumped about 2,150 gigatons of groundwater in that time. And this large-scale water removal has shifted the Earth's tilt and rotation. After we use groundwater, much of it eventually flows into the oceans, contributing to rising sea levels. In areas like Western North America and Northwestern India, people use a lot of groundwater, and it may have a connection to these shifts. Yikes! Let's face it, all these findings are rather disturbing. But understanding the impact of groundwater use is already a huge step in the right direction. Hey, I'm not done yet. This tilting issue isn't just about stuff happening on Earth. We also need to look at space. We've talked a lot about water, right? Well, you know that the moon has a big role in that. Its gravity is super important for forming tides and all that. So one more thing that affects our planet a lot is the gradual movement of the moon away from Earth. These two bodies interact gravitationally, which makes Earth's rotation slow over time, even though significant events like earthquakes occasionally speed it up temporarily. How did we figure it out? Glad you asked. Once, someone paid attention to ancient corals. After analyzing them, scientists realized that Earth had once rotated much faster. The thing is, corals grow by laying down thin layers of calcium carbonate. They do it daily, and variations reflect seasonal changes. By counting these layers, scientists have calculated the number of days in a year millions of years ago. They found that Earth had about 420 days per year 444 to 419 million years ago. But over time, the moon's influence had caused Earth's rotation to slow. And now we only have 365 days in a year. I feel robbed, At the moment, the moon is moving 1.5 inches away from Earth each year. That's about the same speed at which your fingernails grow. Astronomers have figured it out with the help of special mirrors placed on the moon during the Apollo missions. For over 50 years, researchers have been sending laser beams to these mirrors and measuring the time it took for the light to bounce back. In any case, dear Earth, at the moment, your condition isn't critical. As for your inhabitants, they won't fall off your surface. All thanks to your gravity, pulling them toward your center. Just don't switch it off, and everything's gonna be fine. If you were visiting Earth from another planet, your rational mind just wouldn't understand how singing dunes and moving balls of lightning were scientifically possible. I bet you'll feel like these images are just stills from your favorite sci-fi movie. You better hope you never find yourself alone near Catatumbo River in Venezuela during one of its lightning storms. Because if you were, you'd be surprised to find out that lightning works both ways, meaning it can come from the sky and from the ground. Terrifying, I know. Scientists think that in this case, it probably happens because of a high presence of uranium in the bedrock. But it can also happen due to cold and warm air currents that meet around that area. This makes the electric field get all charged up and the bolt flips, traveling from ground to cloud. Scientists even have a fancy name for it: upward lightning. This special place called Catatumbo River became famous because of its light shows. Actually, the name means House of Thunder in the local language. This phenomenon happens for up to 160 nights a year, and it can last around 9 hours a day. When scientists counted, they realized that the area could produce anything from 16 to 40 flashes of lightning per minute. Now, you've probably heard of Marco Polo, the 13th century Venetian merchant and world traveler. Well, in one of his voyages, he came across what he could only describe as singing dunes. The dunes literally started rumbling, like they were playing drums, and freaked him out so much he thought it was the works of evil, invisible entities messing with him. Fast forward to our times, and scientists have discovered how sand dunes produce these rumbles. A team of scientists studied a singing dune in Morocco. They chose a large, crescent-shaped one that makes noise all year round. If the wind is right, this dune can sing a few times every afternoon. It turns out that the wind forces sand to accumulate at the top of the dune until the angle of the slope reaches a tipping point of about 35 degrees. This accumulated sand drops down like an avalanche, and that's what produces a sound. The sand needs to be dry enough for the singing to happen, though. They're like nature's boombox. Isn't that something? This next one might be the most disturbing of them all. First, you'll see a flash of lightning, then a thundering boom, and finally, a curious light floating through the air and bouncing off surfaces like a white electric ball. Would you also hide under your blanket if you witnessed something like this? That's what an old lady did when she witnessed this from bed in her Chicago apartment. It turns out, people have been swapping their own ball lightning stories for hundreds of years. An English monk's report from the early 1000s might be the oldest version of these accounts. It talks about a fiery globe descending from a storm cloud and falling into the river Thames. The thing is, scientists aren't entirely sure what causes it, but one theory involves lightning striking silica-rich soil. This can vaporize silica, creating tiny particles bound by electrical charges. When these particles react with oxygen, they produce glowing orbs, which can last a few seconds. Some other theories say that it can be linked to miniature black holes, or even hallucinations. But the silica explanation is the best contender so far. What they know for sure is that ball lightning is often linked to stormy weather. If you'd wake up in the middle of a wintry night and saw these lights, you'd probably think otherworldly people were invading our world. Or you'd feel like one of the lucky people who got to see the northern lights during your lifetime. But none are correct. These beautiful shafts of pastel-colored light were photographed by a guy in Ontario, Canada. They happen when tiny, flat ice crystals that usually reside up in the atmosphere float closer to the ground. They're sometimes called columns of violet light, and they reflect light from sources like streetlights or cars. These reflections stretch into tall, colorful columns that look like they're glowing in the sky. The best part is that it's mostly an optical illusion. The pillars aren't really in the air. They're just a trick of light bouncing off the ice. Somewhere near Buffalo, New York, you'll find a surreal combination of the fire and water elements. This phenomenon is called the Eternal Flame Falls, precisely because it never stops burning, even if it's so near the water. This is due to a chemical reaction where gas leaks out of the ground and combusts with the air. It's one out of a few hundred natural eternal flames around the world. But the 30 feet tall waterfall is probably the most beautiful one. Now, how does it get lit the first time around? Usually, eternal flames can be ignited by lightning, human activity, or something called piezoelectricity, which is basically when certain materials make electricity when you squeeze, press, or twist them. Scientists believe that Native Americans lit these flames thousands of years ago, but that's just a hunch. Have you ever imagined going for a midnight swim and suddenly finding yourself surrounded by a glowing blue haze? As if there were huge cannons of light coming out of the seabed directly into the surface. This phenomenon is rare, but it sure is magical. This chemical reaction is known as bioluminescence, and it can happen in different situations. One example is when tiny algae organisms migrate near the seashores. When these algae are disturbed, they try to defend themselves by glowing, and just happen to create the most beautiful spectacle. There's also a specific place in the world where you can see a similar phenomenon. It's in New Zealand. Hidden deep within the country's caves lie the so-called glowworms. They are the larval species of a fungus that happen to be luminescent. If you're lucky enough to tour around these caves, you'll feel like you're floating inside an underground galaxy. The sky can create lots of different cool phenomena, and this specific one is called a crown flash. If you were seeing it with your own eyes, you'd see a column of light jumping or dancing near the top of a cumulus nimbus cloud. Think of cumulus nimbus as massive, towering clouds that look like fluffy mountains. These are the clouds that usually announce thunderstorms, lightning, and heavy rain. Now, although you'd probably think crown flashes looked like some supernatural energetic door opening to the heavens, this is a very scientific phenomenon. It happens when sunlight reflects off tiny ice crystals inside the cloud. But here's the cool part. Those ice crystals aren't just floating around randomly. They're moving because of shifts in the cloud's electric field. As the field changes, the ice crystals realign, and the light they reflect moves too. That's why the crown flash looks like it's flickering or waving. Crown flashes don't happen all the time. You need a thundercloud with the right conditions, lots of sunlight, ice crystals, and a strong electric field. If you ever spot one, consider yourself lucky. It's like nature showing off a rare light trick. We usually see ever-burning hills in sci-fi movies, but this one is real. Located in the Arctic region of Canada, the so-called Smoking Hills is an unmatched sight on our planet. And here, things get even a little science fiction-y, since some minerals that exist in these hills were only ever found in a few places on our planet and outside it, like on the surface of Mars. The ground of Smoking Hills has been releasing smoke for at least a couple hundred years, non-stop. Explorers thought the area was home to an active volcano, but that was not the case. As science explains, the soil in the area is formed by sulfur and coal, and when they're in contact with oxygen, they spontaneously ignite, releasing constant smoke. I just warn you, don't be getting any touristic ideas. The environment is extremely hostile to human life, as the smoke is toxic and its temperatures are dangerously high.